Welcome! This video is going to go over the worksheet that's posted online for Chapter 9. It's the second half of Chapter 9, so we've been calling it 9b, and this is going to be the in-class review for graphing quadratic functions. So I'm just going to kind of go through this worksheet. You can follow along if you want to, or you can pause it and try a couple problems and then just fast forward to check your work. It's totally up to you how you kind of want to go about the review. But I do recommend that you try the homework review like the test. Pretend it's like a test, take it like a practice test, and then grade it with the key that we'll post online. So good luck. I hope you're well, I hope you're safe, and I hope you enjoy this video. So the first thing I'm going to do is talk about all the concepts that we've been reviewing in Chapter 9, and there's quite a few concepts that are just referring to roots, zeros, solutions, how to graph a parabola, how to find the equation of a parabola, and things like that. So I'm going to start with the first question here that says, find the roots of this picture. Now the roots is also another word for solutions. There's another word that's used, zeros, and then another word called x-intercepts. And that just means where your function crosses the x-axis. So there are 2 points here, and there are 2 solutions for your roots. It would be the point -5, 0, and the point 1, 0. For the 0 over here, your 0 would be -4, 0. But you could also write it if you wanted to. Here x is equal to -5, and x was equal to 1. If you wanted to write like x-intercept is. Now for the next couple questions, they ask just a few more things about the picture beyond just your roots. So they ask things like the vertex, whether the vertex is a max or a min, and then what would be the equation for your axis of symmetry. Now the vertex is going to be the point that's either the highest or lowest on your graph, and this point is at 1, 4. And that is the highest point on the graph, so it would be a max. And the axis of symmetry here would be an equation, and it's always an x equals equation because it's a vertical line that cuts your graph in half. So as you're graphing that vertical line, what x does it pass through? 1, and it should be the same x as the vertex x point that you have. The max is going to be the y value of your point, so it hits a high of a y value of 4. Now over here on this picture that opens up, we have a low point on the graph, and that low point is your vertex. It's -4, -1, and that is a minimum. The lowest it reaches, the y value, the lowest it goes, would be a y value of -1. And the axis of symmetry is an equation. It's a vertical line that cuts your picture directly in half, and that vertical line crosses an x value of -4. Now down below, for number 5 and 6, it says find the vertex and the axis of symmetry from the given equation. Now what you need to know here is the equation for the axis of symmetry, and it is this equation. So I'm going to write axis of symmetry, or AOS, and it is x equals, because it's always a line, x equals a vertical line, and it's going to be opposite b over 2a. And that's something that you probably need to have memorized. So I would work on trying to get that in your, just kind of in your brain, in your toolbox. Now as I'm looking at my function here, my a value in front of my x is -1, my b value is 10, and my c value is -13. So my function here for -x² plus 10x minus 13, my axis of symmetry is going to be x equals. Now opposite of b, opposite of +10 would be -10. And 2a, a here is -1. This is going to make -10 over -2, which is going to simplify down to be a +5. So that's our axis of symmetry. Now the next thing that we're asked to do is find the y-intercept. Now I don't know if you remember this from the notes, but the y-intercept of your graph is always the c value of your function. And my y-intercept is going to be at 0 and a y value of c, -13. And that's just something that you would have to have remembered from the notes. Again, kind of like this, you'd have to have remembered opposite b over 2a. Now the vertex, what we're going to do is we're going to plug in an x value of 5 and get out the y value of the vertex. So take the number 5 and plug it into every x that you see in your function. So here we go. We're going to take f of x just really means y. So the y value is going to be opposite of 5 squared. We're going to plug that 5 in, plus 10 times, now plug in 5 again here for that x. And now we're going to simplify. You have to apply an exponent before you multiply by -1. So this is going to be opposite of 25, because that's 5 squared, plus 5 times 10, or 50, and then minus 13. Go ahead and use a calculator. This is going to make 25 when I add the first two numbers together, and 25 minus 13 is 12. So there's going to be the vertex of my function. Now number 6 is going to work similarly, but here you're starting out in a different form. So you have a couple choices here on how you want to find the axis of symmetry. You could find first your x-intercepts and then find the middle of those 2 points, or you could FOIL this out and get your equation in standard form and then kind of do what we did over here. And so I'll show you both ways. So because this is not in standard form, a shortcut to converting it to standard form and then doing what we did over here would be to do this. So because we're starting here in factored form, and this is standard form, see how these are your factors, I'm going to tell you that your x-intercepts come from setting your factors equal to 0. So if x plus 18 was set equal to 0, your intercept would be -18. And if your x minus 12 is a factor, if you set that equal to 0 and you solve, your x-intercept would be +12. Now, what would be in the middle of these two numbers? Well, you just do an average, add them up and divide by 2. So your axis of symmetry is going to be -18 plus 12. We're going to add those together and cut them in half because we want the middle. This is going to make -6 divided by 2, which is -3. So my axis of symmetry is -3. Again, your factors will help you find your x-intercepts, and your x-intercepts on your picture, your axis of symmetry should be right in the middle. So here I'm just taking an average. Now the y-intercept. Over here what we said was that your function, if it's in standard form, the c value is going to give you your y-intercept. Well, there's a shortcut to this if you want to realize that your y-intercept comes from when x is equal to 0. So you could just plug in 0 because we know the y-intercept has to be 0 comma a number. We'll just plug 0 in. So my function is y equals, my function y equals -0 plus 18 and 0 minus 12. So if you remember that a y-intercept, we're looking for the y value, x has to be 0, so just plug 0 in. This would be, if I simplify now, opposite of 18 times -12. If you multiply those two numbers together, I need a calculator, hold on just a moment. Okay, -18 times -12. I get 216. That is going to be my y-intercept. Now, my vertex has to have the same x value as my axis of symmetry. And I already know what that is. Kind of like I knew for a y-intercept that x would be 0. Well, I know for my vertex, it needs to have the same x value. So I know it has to be at -3 comma something. Well, I'm just going to plug in -3. Opposite of -3 plus 18, oops, forgot my 1, and then -3 minus 12. This is going to be opposite of 15 if I add -3 plus 18, and then -3 minus 12, -15. And if I multiply those two numbers together, I didn't write my answer up here, this one was 216, but this, if I multiply -15 times -15, oops, I get 225. And that is going to be the y value of my vertex. Now, If you liked what we did over here and you only want to have to memorize one thing, you could have just multiplied these two binomials together and put this in standard form to then do what we did over here. Opposite b over 2a, plug that number in, you find the y value of your vertex, and then you just use c of your function for the y-intercept. So if you want to, you could have, and I'm just going to flip my paper over here to show you, you could have done, here was your function, you had opposite of x, what was it, plus 18, and then x minus 12. Just gonna double check that. And then if you wanted to, you could have FOILed this out, take your x times x and x times negative 12. I'm gonna leave this opposite out here for a second. X times x is x squared, x times negative 12 is negative 12x. Now that I'm done multiplying my first component of my binomial, I'm going to multiply my second. Here we go. 18 times x is 18x, and 18 times negative 12 is negative 216. Now I'm going to combine my two like terms in the middle, and I'll have x squared plus negative 12 plus this 18x is going to be 6x minus 216. And now distribute that negative that we had out in the front. Opposite of x squared, opposite of positive 6, and opposite of negative 216. This would be your standard form. And then you could have done like we did before. Your axis of symmetry is opposite b over 2a. You should get the same exact answer. The c value, look at how it matches, 216. It matches what we had over here. Thank you so much for listening. I'm going to pause here and I'm going to do another video for the next page of your review packet.